Operating the Macaw web browser interface. An overview. Tetracam highly recommends that customers consult the Macaw user guide for detailed instructions. Take Picture does what you would expect. It takes a picture, but the way in which it does so depends on the current Macaw settings. Right now it's in triggered mode, so if we press the button once, it'll only take one picture. If we change it to continuous mode, pressing the button once will cause it to take pictures until you press the button again. Erase Pictures does just that, but it's important to know that it erases all of the pictures in the Macaw, not one at a time. Set Time Date synchronizes the time and date with what the time and date of your control tablet or PC is. However, the time it displays in the status is UTC time, so it will be however many hours different from where you reside based on your location in relation to Greenwich, London. Edit Vegetation Index allows you to specify vegetation indices in great detail, so that the Macaw does what you want it to do with indices in its background processing. To begin with, you could specify what index you want. The choices are NDVI, IPVI, SAVI, GARI, and the -M versions of those as well as RGB extraction. Then you could specify what bands you want to use for each index that you've chosen. Finally, you can optionally select what palette file you want to use with your index. Shutdown shuts down the Macaw camera application as well as the Linux system that the Macaw operates on. Once the LED turns orange, it is safe to unplug power from the system. Format Sata formats the Sata hard drive in the Macaw, which is useful when you have numerous pictures that you want to erase, or you want to format the hard drive for any other reason. It's more convenient than formatting the hard drive any other way. Edit Settings is where you edit the various settings for the Macaw. Notice that every setting has a help button next to it. Tetracam highly recommends that you refer to each help button as appropriate, as well as the Macaw user guide when you are operating the Macaw in any fashion. Let's briefly overview relevant settings. Code version and serial number are both unchangeable. The serial number is your Macaw serial number, which is also located on the front of your Macaw. Metadata format can be either GPS NMEA, Robota Goose, Pixhawk, Mavlink, and Tetracam ILS. That data comes in on the round serial port connector on the interface end of the unit. In the case of the Tetracam ILS, it's both ILS and GPS data coming in on that link. But if you don't have a Tetracam ILS and you just have a GPS, it will recognize GPS. Console serial baud is important for not only connecting via serial console, but also certain types of GPS units. Choose the value that is appropriate for your situation. Tetracam recommends using 115/200 when connecting with a serial console. Field of view reduction can be explained this way. When an image's planes are aligned, rotated, and scaled so that the pixels all correspond, sometimes you'll have a little border of black pixels because one image has been scaled down or rotated a little. You can reduce the field of view by a small amount. That is, crop a center rectangle out of the set by setting a value here. For example, 2%. Not a huge change, but it'll get rid of little black artifacts on the edges of the image when they're aligned. Number of bands is not configurable. It's set at the factory. UTC time offset tells the Macaw what time and date to give to the pictures it captures in relation to UTC time and the value you set. In other words, if UTC time is 22 o'clock and you set a value of -8, your pictures will have 14 o'clock for the time they were taken. Camera mount really doesn't do anything to camera operation, but it goes into the TIFF metadata to tell other applications how the camera is oriented with respect to the direction of flight. So you could change it to portrait if you'd like. And that helps with some tiling algorithms and may be useful. The image index lets you change the number of the next picture taken. For example, you could change it to 100 so the next picture will be image 100. Selecting the language means changing the web browser interface to reflect the language selected. Currently, there are 4 languages available to choose. Image dimensions can be full size or half size, so either 1280 by 1024 or 640 by 512. Capture mode tells the camera what it's going to do when it takes a picture. Triggered takes 1 picture per button press. Continuous takes pictures till the next button press. In other words, when you press take picture, it'll keep taking pictures until press take picture again. External start stop is like continuous, but with a control logic level as opposed to a start stop trigger. GPS offset will trigger the camera based on GPS feed that the Macaw receives. It will either trigger at every message from the GPS it receives, or it will wait until a certain distance is reached before it triggers. Both of these actions depend on what value is set in the GPS trigger offset box. If 0 is set, that is when it will trigger after every message. Otherwise, it will trigger based on distance value set. ILS GPS baud lets you choose the baud rate for the ILS GPS port on the Macaw. There's a log file as with all Tetracam MCA cameras. The logging can be off or it can be brief, which is what is most useful for a mission that has GPS input, or it can be verbose and show GPS messages that may contain parity check errors and such. Align planes allows you to set in what way you would like the Macaw to align its image planes from all its sensors. No plane alignment tells the Macaw not to align the planes, meaning that it makes a multi-page TIFF, but it doesn't do anything else with the data. Forced with capture aligns the image planes immediately after each image capture. Background align aligns the image planes in the background while the Macaw takes pictures. And BG align and extract does background alignment and also generates extractions of those aligned pictures. Mosaicing programs are under development presently by Icarus, and when they have a production version, you'll be able to turn this on and get a low-resolution mosaic of the pictures on the mission as they are acquired. If you have an ILS unit, you can disable it by setting it to disabled or turn it on so that pixels are automatically corrected in the camera based on ILS measurements that are coming in. Should be noted that none of these things, ILS adjustments, plane alignment, index extraction, need to be done in the camera. They can be deferred till later using Pixel Wrench from Macaw. There are 2 file formats, 16-bit TIFF and 8-bit TIFF. 8-bit TIFF is twice as fast. 16-bit has more precision. The camera supports a fixed exposure setting in microseconds. Basically, you type in what you want for a fixed exposure like 5000, and it'll use that in the next picture. If you're in auto, which is 0, you can have the auto exposure try to set the average of the field of view to 50% by setting control average, or you could try to have it control the peak values. Control peak, which generally produces darker images than the average control. So all these things are set on this page, which is a form. You'll notice this is an HTML page, and the HTML pages are resident in the camera and can be edited and modified as the user may desire. You can even rearrange the controls, make the buttons bigger if you have a smaller smartphone that you're using, assuming you have some expertise with HTML or PHP composition. Live View is still currently under development. When it's finished, you'll be able to pick a band to view in a live view window. Linux has a scheduling routine called cron, and we allow you to have a cron tab for the camera so that you could set it up for slow elapsed time photography. It's actually a Linux utility. There's copious help files available on the camera to explain how it works. So if you ever need time-lapse photography, it's there. Array calibration displays the bandinfo.txt file. These are X and Y translation values for each plane. We mechanically adjust these pretty closely. You'll see there's no more than a 1 pixel adjustment for X and Y translation for any plane. These are the rotation values, which are slight differences in the positions of the sensors on the circuit board. These are the scaling values, which are slight changes in the magnification factor of the various lenses. We have band IDs here. Then the relative exposure values for that band to produce a neutral gray image. If we had an ILS, the ILS calibration values would be here. The camera status box displays relevant information. Picture count, which is updated upon image capture. Time, which is based on UTC. Metadata, which usually displays GPS information if there is any. Pictures left till the hard drive is full. System information, and background process, which displays when the camera is aligning planes or extracting indices. Below the camera status box, there is a drop-down list where you can select a picture that is currently stored in the camera. Beside that, you can refresh the list, display an image in the list, and delete one image at a time. Below that, the forward and back buttons consecutively display the next image. The drop-down list to the right of the back button allows you to select the band you wish to display for the current image. Zoom in out allows you to zoom in or out of the picture displayed. View metadata allows you to view the metadata for the image selected. Finally, the drop-down list at the bottom of the screen allows you to select an extraction of the image selected.